Welcome to the second problem solving session for rectilinear kinematics. In this problem, we use a car that involves a real life scenario. For example, you are driving on a street and in front of you there is a traffic signal, and then suddenly the yellow light goes to red, and you press your brake to stop before the red light. So what could be the scenario? Do you go over the mark, or could you be able to stop before the line? So those kind of problem we're gonna solve in this problem. So let's see what is the problem. It says a car is moving along a straight path. So this is the assumption: straight path, meaning rectilinear motion, at a speed of 50 mile per hour. So what are the things given are knowns? Knowns are u equals to 50 mile per hour. Now see, the unit is not a meter in second, so I would like to convert it to meter per second, and the conversion is 0.447, so we got 22.35 meter per second. So this is the unit conversion. It also says that the driver noticed an obstacle it should be 20 meter ahead of the car. So obstacle at 20 meter distance, and the driver applied a brake of acceleration a of 10 meter per second square. So since acceleration is constant 10, the assumption is continuous motion. Therefore, we can use all the four formula that we have derived in our previous class, and we can use this equation and hope it will be much easier and avoid integration and differentiation to solve the problem. So what are the unknowns? The unknowns are how long, meaning time, does it take to stop the car. So time t to stop the car. Determine if the car was able to avoid collision. So the driver applied the brake, but whether the car will stop before hitting the obstacle, which is 20 meter away. So collision or not. And if yes or if not, what would be the minimum deceleration to avoid collision? So how to avoid collision? So this is the second question. This is the third question, is how to avoid collision. Okay, so now we can start solution. So knowns are initial velocity and acceleration, and we know that the car is going to stop, meaning the final velocity is 0. So when we have this formula from this knowns, we can use from the four formula. The simple one is final velocity equals to initial velocity minus acceleration into time. So this will give us the time. If we plug the value, 0 equals to 22.35 negative minus 10 into t. So if we solve for time t, we see that it is 2.23 second. So this is the time that is required the car to stop, to come into stop. So this is after he applies the brake, the car will take 2.23 seconds to come to stop. Now we need to see, the second question was whether there will be collision or not. So we need to find how much distance it will travel at that time. So we know ut minus half 8t square, because it's a deceleration. If we plug the value, initial velocity and time, u multiplied by time 2.23 gives us 49.84 minus the half into deceleration 10 into t square, time is square, so 2.23 whole square, that is 4.973. So if we solve this, we get the distance 24.865 meter. So we found that the obstacle was 20 meter away, so s is greater than 20 meter. That tells us collision will occur, collision will happen. So we need to come up with a solution how to avoid the collision. One of the way is that if we could brake at higher acceleration rate, we could have make the car stop earlier. So that's what we'll be looking for. To find that, we'll be using the other second velocity formula, which is v square equals to initial square minus twice as. Because now we selected this equation because we know initial velocity, we know that the maximum s could be 20 meter. We are looking for the minimum acceleration that will stop the car exactly at 20 meter. We can always go higher than this, the minimum acceleration that we'll be finding. It will stop before 20 meter, but we want it to stop at 20 meter, and then the question asking for minimum acceleration required to stop it. So at the stop point, final velocity is 0. We know the initial velocity is 22.35 whole square minus 2 into 10 into 10. We're looking for the acceleration, so we'll keep that, and then the s displacement is 20. So if we solve, we get acceleration is 12.5 meter per second square. So this is the minimum acceleration mean required to stop the car to avoid the collision. So this was our final unknowns that we found out. So we have answered all of the three, so we solved the problem.